in the previous 8 lakh years, the amount of carbon dioxide, the main greenhouse gas, which is responsible for causing global warming, along with a host of other greenhouse gases, of course, has exceeded in its amount uh, uh, the level of 300 ppm. And now, as of 2016, the level exceeded even 400 ppm. And the pattern in which carbon dioxide and other greenhouse gases has actually fluctuated over the planet is very, very similar to how temperatures are rising, especially in the period since when the industrial revolution has started. And that is kind of watershed in human history, the 1880, from where climatologists have both constructed and reconstructed instrumental data with which they are reconstructing all the temperature series. And this is very telltale actually, that how temperatures are continuously rising over the earth. And by now, as per IPCC report, as of now, the earth has warmed additionally by about 1 degree centigrade over its globally average normal, which is around 14.5 to 15 degrees centigrade. So the whole of planet is undergoing this phase of human-induced global warming, and every inch of the planet is undergoing the same phenomena. So Northeast India definitely is no exception. And scientists have estimated that, by 2100, if things go without any change in the business as usual scenario, the temperatures might rise beyond 4 degrees centigrade. And that's why humanity has committed to itself that it will not allow the global temperature to rise beyond 2 degrees centigrade as per the proposition in the climate summit in Paris, the Paris Agreement. Now, coming to the geography of our interest, this is Northeast India, which is, literally a very distinct region in India, be it geologically, be it climatically, be it physiographically, culturally, ethnically. So this region, we all admit that needs very, very special focus and discussion as far as any kind of environmental change, including climate change, that might be happening, and that might be impacting different aspects of people's lives and livelihoods. Starting with this very beautiful map, which is nothing but a vulnerability map of Northeast India. Just to go back to the first slide, for us, Northeast India is inclusive of Sikkim and North Bengal. And when we talk about an independent, the entire climatic or hydroclimatic region, it includes both Sikkim and North Bengal. So this is a vulnerability map of Northeast India, originally sourced from Isimo, Kathmandu. And here you can see the darkest brown patches as being the most vulnerable ones. This vulnerability is mainly, with respect to water-induced hazards, mainly, flood, erosion, and other kind of climatic and hydroclimatic hazards. And you can see that a large portion of this whole area are extremely vulnerable, or at least moderately vulnerable. So in this context only, we will start our discussion, starting with, whenever we talk about global warming, and climate change is the other aspect of the same coin actually. So the first thing that comes to your mind is what is happening to the temperature regime, and then what is the situation in a rainfall regime. That's what we are going to ask actually. So there are many estimates, a number of estimates of assessing climatic variability and change in terms of temperature regimes and rainfall regimes for Northeast India. And in this slide, and as well as in the whole presentation, I have actually chosen to pick up some of the most plausible, most logical reasonable assessments which has been done by various groups of researchers and scientists throughout the world, and I've collected and collated them to and then I will try to join the dots to tell you the whole story. So, like the entire globe, entire Indian subcontinent, over Northeast India also undoubtedly temperatures are rising. So Northeast India is also undergoing uh, global warming, uh, and just to read out some of these statements. The rise in temperature in the Northeast India, with respect to what was in 1970s is ranging from 1.8 to 2.1 degrees centigrade. So mind it that the global warming by far is around, hovering around 1.0 degrees centigrade. So the Northeast India, people have estimated that uh, in some places, at least it has risen by more than 1.5, more than 1.8 degrees centigrade. So there are some, projections about the future temperature also. One estimate says that between 2021 and 2050, it is likely that temperatures will continue to rise and may rise beyond 1.5 to 2 degrees centigrade. And the other, prediction is that the seasonal temperatures are also rising. It's not only the mean temperature, also seasonal temperature, especially for Northeast region, the pre-monsoon and monsoon temperatures and the winter temperatures are very, very important. And all these seasonal components are actually rising along with the mean temperature. A recent study by Das et al. 2012 has predicted that there will be and there is likely an increase in the annual mean surface temperature by about 0.64 degree centigrade, in the next 30 years from 2011 to 2040, and which could also reach as high as 5.15 degrees centigrade by the end of this century. So between 1951 and then 2010, the mean surface air temperature in Assam, in this case we are talking about Assam, increased by 0.01 degrees centigrade. So if you multiply it by 60 years, because it has happened over the 60 years, you will see that the temperature has roughly increased by zero point 0.6 degrees centigrade over Assam. These data and these results have been derived from various sources of scientific work. The other very interesting observation is that the number of cool days is decreasing while number of warm days is increasing. I'm sure while I'm reading out these, these results to you, you might be able to connect your daily experience or your seasonal experience of what you have been feeling over the last couple of years, and trying to connect to whatever the scientists are actually saying. For example, to take this particular prediction, or this is actually a current observation. The number of warm days is increasing, the number of cool days is increasing. And this is, we have carried out a lot of anecdotal evidences all over Northeast region, and this is in tune with most of the popular experiences. Yes, they're experiencing more and more summer days, more and more hot monsoon days, and then less and less cooler days in last couple of decades. So this speaks for itself. Now let's try to see what is happening in the rainfall regime. So this is from a work which has been very recently published by the Indian Institute of Tropical Meteorology, SPUNA, who's a Government of India institute. And on the screen, you can see the map of India, where all the meteorological subdivisions are shown. And in Northeast India, there are 4 meteorological substances, meteorological subdivisions mainly. One is Arunachal Pradesh itself. The other is Assam and Meghalaya. The third is Nagaland, Mizoram, Manipur, Tripura. And the fourth is South Himalayan, West Bengal, and Sikkim, right? And let's see what is happening, how the rainfall is trending in over the region as a whole, and as well as the subdivisions. Now, the mean seasonal rainfall for, you see, the summer monsoon rainfall is most important agriculturally, economically, climatically, environmentally for India as well as for Northeast India. So here is an assessment of how the summer monsoon rainfall uh, has fluctuated over the last more than 1 century, as well as for a smaller period. So the mean seasonal rainfall of Northeast India for the recent period, which they have defined as for last 35 years, which is between 1981 and 2016, is significantly reduced from what was there during 1871 and 1980. That means during 1871 and 1980, definitely there was a gentle reducing trend in the total rainfall of this region, but of late, the reduction in rainfall is more evident. Statistically, it is more significant. Similarly, during the recent period, I mean, during the last 35 years, the two subdivisions, Assam and Meghalaya, and South Himalayan, West Bengal, and Sikkim, have shown very significant decreasing trend in rainfall, which is 10% as far as level of significance is concerned. Similarly, during the entire period uh, of last 145 years, from 1871 to 2016, two subdivisions from Northeast region, the Assam and Meghalaya subdivision, as well as the Nagaland, Manipur, Mizoram, and Tripura subdivision, they have experienced significant reduction in rainfall. So the sum and substance of the rainfall story is that of late, in last 35 years, in last 30 years, starting from 1980, rainfall in general over the region is showing a decreasing mode. Again, the probability of occurrence of deficit monsoon has been found to be the highest over Assam and Meghalaya. So these are all assessments made by our country's climatologist. So statistically, when they plot it on a diagram, and if you can see, you can focus on the rightmost part of each and every graph. You will see the how prominently rainfall is decreasing from 1980 onwards. So in that sense, 1980 signifies kind of a regime change in the climatic regime of the whole country, as well as for Northeast India. So this is for the entire Northeast India itself, and of late rainfall is decreasing. Now you see this is for the Assam and Meghalaya part of this subdivision, meteorological subdivision. Here also you will see a very sharp fall in rainfall trend in the recent epoch. Again, this is for Nagaland, Manipur, Mizoram, Tripura. Here, the fall has remained prominent even for a longer period. Even from 1970s onwards, it has entered into a below rainfall epoch, and now it is reducing more sharply. Now, even over the Sub-Himalayan and West Bengal and Sikkim part, where the mean rainfall is quite high, even the highest in Northeast region, you can see a very prominent, downfall in rainfall. So, what has happened, what has been observed in recent times in case of rainfall is mostly telling you the story that rainfalls, these are aerially, averaged or weighted rainfall over large regions. These are, decreasing, but there can be exceptions when you come to smaller areas, when you come to individual station level rainfall. You might have quite a few rainfall stations showing increasing trend. That's a different. But when you average it out on a larger region, then it shows more or less a reducing trend. And when we come to, oh no, uh, but when we take the whole region, we don't see any statistically significant in case of the mean annual rainfall. What we were just talking about was the summer monsoon rainfall. In case of the mean annual rainfall, there's no statistically significant trend. For Assam, the mean annual rainfall has also slightly decreased since 1951. There are some other observations from various scientific groups. For example, one of it says that actually the frequency of heavy precipitation events is increasing while the light rain events are decreasing during the last century. This is also an example with which some of you might concur, or some of you might, have, would have supported from your own experience. Then another prediction is that the monsoon rainfall, that means the rainfall that there's floods happening, a lot of there's rainfall happening. So for us, actually, anecdotally, uh, we are quite, familiar with the fact that but one interesting, prediction, which is also an observation, is that of late winter rainfall is decreasing, and in future also winter rainfall in Assam might decrease, and this has a lot to do with our rabi crops. For farmers. So this is more or less the story about rainfall. Then another important aspect when Brahmaputra is the largest river system here, and some amount of scientific work has been done. So we know that Brahmaputra is most susceptible to the reduction of flow, threatening the food security of an estimated about 26 million people. And one very important prediction about the flow of Brahmaputra, which has come recently, is that the flow in the Brahmaputra basin uh, will increase, due to accelerated glacial melt, because we know that Brahmaputra has a glacial link in Tibet, till about the fourth decade of this century, to about 2045 and 2050. But the overall summer and the late spring discharges are eventually expected to be reduced consistently and considerably, at least by 19.6% on an average during the years 246 to 2065, which in simple word means that initially for next 20, 30 years, there will be more water, more floods in the Brahmaputra because of excessive melting of summer, thawing of the snow in Tibet, uh, for the mainstream as well as some many of its tributaries. But after about to the sixth decade of this century, uh, the flow will start decreasing, and finally some other work by other scientists have also expressed the fear that even a river like Brahmaputra might become a seasonal river, might get converted from a perennial river to seasonal river. So these are different scenarios actually portrayed by different scientific groups about what is going to happen in this Himalayan region. I have used this very meaningful diagram, this statistical table, as well as some diagram from the Brahma Twin project with permission from Professor Bulgang and Water Resource Department, Government of Assam. Here you can clearly see actually how the flow regime of the flows in Brahmaputra will be decreasing in under different kind of climatic scenarios.
Partha,
So then,
Partha,
yes,
I just want to
yeah,
interrupt. We have about 8 minutes remaining to the session of the
uh,
total 40 minutes. So if you could just leave 2-3 minutes for the discussion, maybe you have another 5 minutes.
oh, we have 8 minutes only.
Yes.
Okay, I'll go first. Yeah. Now, the second part of this, this whole thing is if in that context of what is happening to the climate regime of Northeast India, you can actually draw kind of a menu of hazards or hazardous situation that might get unleashed on you with more intensity and frequency. These are already there. The natural disasters are already here. What climate change will additionally do to these disasters is they will make them more intense, more frequent, more devastating, and more unpredictable, very difficult to predict and prepare for and manage. For example, rainstorms. We already have extremely heavy rainfall, extremely heavy rainfall called cloudburst, part of cyclone. We have thunderstorms. We have flash floods, and different kind of debris flow. We have landslides and landslide dam outburst flight. We have glaciers in the Himalayan region and as well as in Bhutan, where the glacial lake outburst floods could be related to some of the flooding in some of our rivers. We have riverbank erosion, which is related to more and more sedimentation because of extreme rainfall. We have land degradation due to siltation or sandcasting in popular language. Then we have shifting river courses, and recently we have also added the phenomenon of lightning, which is very prominent these days in the pre-monsoon season. Then we have river dam induced flooding. Dams are a new addition to the rivers of this region. Then we have reduced environmental flow in our normal rivers. We have situations of water scarcity, basically for drinking, irrigation, and agriculture, because of consistent below normal rainfall. We have drought-like situations. Uh, we have crop failure, reduction in production of tea mainly. Crop means any other kind of crop. We have waterborne diseases, and recently Assam and some other areas also have experienced heat waves. Now, some of these are expressed pictorially. Now we have more flash floods, devastating more and more riparian areas than normal floods. The erosion is influenced by more and more river sedimentation, which triggers more and more from extreme rainfall events in hills. The famous flash floods of the Western Assam in 2004 and then 2014. The famous Yigyong flash floods, which happened in Tibet, but devastated part of Arunachal Pradesh and Assam in Dhemaji. Then we have a highly and a large stretch of silted and sandcast area, which deprives farmers of their productivity. We have drought-like situations becoming more and more intense since 2005 till last year. Last year also there was a 38% deficit pre-monsoon rainfall, causing widespread droughts. We have water scarcity scenario like this because of change happening to the groundwater level, subsurface level, and also surface water bodies. We have landslide giving rise to, because of landslide dam outburst flood giving rise to flash floods happening more and more frequently in Bhutan, in the Arunachal, Assam, Meghalaya, Assam landscape, in Bhutan, Assam landscape. We have these potentially dangerous glacial lakes contributing floods to some of the tributaries which again contribute to rivers like Manas, Sonkos, Raitak, etc. that affect both Assam and North Bengal. We have a number of dams, both on place and a lot coming, which have the potential of complicating the flood and flash flood situation even more. And the most recent addition to climate-induced hazard, which was never so prominent in Northeast India, is the heat waves. We had very prominent heat waves episodes in 2006, 2008, 2015, even 2019 last year. Now, Assam is normally experiencing more than 35-degree temperature a day almost every year, and highest being 39.2 degrees centigrade. Lightning has been added to the new menu of climate-induced disasters because it's happening more and more widely all over Northeast India. Similarly, there are many other sessions, but to end with my presentation, let me refer you to a very recent study of Department of Science and Technology, Government of India. They have done the assessment of climate vulnerability of all the Himalayan states in Northeast India. Out of 12 states, it has been found that Assam has the highest vulnerability and Mizoram has the second highest vulnerability. Here is the reference of this report. I will insist that all of you who are interested in climate change, especially in the Himalayan area, should go through this, very well managed report. And the vulnerability scales and levels are given even to the district level of all northeastern states. And finally, this is the last slide of my presentation. This simply shows that how you can start with theoretically with global warming, climate change, and then you can actually logically connect a lot of hazards and hazardous situation you see on ground in all over Northeast India, and how you can logically connect it to one or the other aspects of climate change and global warming. Thank you very much. That was the end slide of my presentation. So I tried my best to give you a very holistic, integrated idea of how different kind of hazards can be linked to the existing climate change situation. Now, Udayan, I'm ready for questions.
I don't think we will have time for question because it's less than 1 minute as Zoom shows. So what we can do, we'll download all these questions and we can answer them in a different platform. Maybe we can reply them through email as well. So
I can respond to all the questions personally.
Yeah. So I mean, we'll download all the questions and you can write answers to those questions and we'll communicate back. So that would be the option, because now we'll get disconnected anytime. So anyway, I'd like to thank Partha as well as all the participants for joining us today. And we'll keep on organizing this webinar. So keep following us on social media and through Facebook or Instagram, and keep joining. Thanks a lot.
Thank you very much to all participants. Thanks to the hosts.